Hi, my friends, to this new episode of Writing System Software. I am in my office, those are my best friends, and let's see what we can do today. So, we left with our small server, and I can enter here and chat. Ciao, hi, how are you? And in the other side I will see this message. Let's see the biggest shortcoming right now from the point of view of the chat client, not the server. So imagine that I'm typing something like how old are you? I am 40. How old I am? Almost 47, but 46 for now. Years old. And now, if while I am writing my sentence, but didn't hit enter still, if another user types something, this is what happens. In the middle of what I'm writing, I see user 5 blah blah blah, and that's frankly uncool. And I can continue writing, and I can see that the whole sentence was transferred to the other user, and so forth. And this happens because basically in this case Netcat is listening at the same time to the socket and to the user input. However, from the point of view of Netcat, the user input will be complete only when I write the new line, because it implements buffering. So as I write, this only is in the operating system TTY buffer. Only I hit return. Finally, we will trigger the standard input as readable, and Netcat will read it and will write it to the socket to the other hand. So, in order to understand how to fix this, let's start writing our client at least to the point that it is able to do what Netcat can do here. Small client, and I did it already for you, otherwise this would be super boring and slow and long video. And this is our client, where we basically use the same stuff that we used when writing the server in the first episode. So we have just a main function. This is so small. It's 47 lines of code, 34 comments, almost as comments as C lines. So that's what we want to do. We get a host name and a port, and we want to create a TCP socket. So I wrote this TCP connect here, and I put all our library stuff into the chat library C file. That's what TCP connect does. It takes an address and a port and a flag to tell if we want or not non-blocking connection. We write the port as a string, and then call get address info, which is something like a more advanced form of get host by name. Basically, this will hit the DNS server if needed, if the address is an host name, or if it is just in numerical form, it will just translate the address into our structure address info. At this point, we can create the socket of the right family, because it could be IP4 or IP6 address. and I have my socket, which will be of type sockstream, so TCP socket. Then if non-block was passed by the user, I call my old function, the one we saw the last time, to set the socket in non-blocking way. Oh, finally I can use connect. In case the socket is non-blocking, connect is slow. You know, it requires the TCP protocol to do the three-way handshake and so forth, so it will return in progress if the socket is non-blocking. Otherwise it will block and will return as soon as the socket is connected, or if we received an error from the TCP stack. And finally we return S, and we free our address infrastructure. That's it. Super simple. Again, should be some kind of C library call, but no. You know, if we have these simple functions, the C language is no longer so intimidating. It looks like high level. So my socket is TCP socket connected, blah blah blah. If there is an error, do something. Then I use again multiplexing, because I want to listen at the same time from the server, and I want to listen also from the keyboard inputs. So yeah, I set up a read file descriptor set, and I set my socket and the standard input file descriptor. To get the standard input file descriptor, I can use this function that is standard C function, file number. I call select, and then if my socket descriptor is ready, I read from the TCP socket from the chat server, and I write the standard output. Otherwise I do exactly the contrary. I read from the keyboard and I write to the server what the user is typing. GCC smallchat client 1 minimal viable product chatlib.c smallchat client. Okay, this is the server. Let's check if our client is sending data. Yes, and it also received data. Okay, let's try also with netcat. Okay, so our chat is working as expected. Basically, I can write with netcat, I can write from the telnet session, and I will receive the same exact data in our client. However, this client will have exactly the same shortcomings that we saw before. So if I am in the middle of a line and data is arriving, okay, I can see here this garbage. That's not cool. How it is possible to solve this kind of problems? Well, intuitively, it is very simple. We need basically, when we want to write something on the screen, we want to, for a moment, hide what the user was typing, print the message arriving from the chat, and then restoring what the user was writing, so that it was typing, so that the user can type more. However, right now what happens is that as I type, the program is not really in control of what is happening, or cannot receive the data I'm writing, because normally the terminal TTY will perform some work before the program together with the kernel of the operating system. So it's buffering our data, and the program will just see it when it's too late, when the user types the new line. To fix this problem, I have to use raw mode. Basically, to set my terminal in raw mode, I need to read the terminal settings of the current terminal, and then I have to backup the original terminal settings so that when the program exits, it can restore back the normal modes. And then I have to enable the raw mode. How can I enable it? Basically, I change the original terminal settings, removing from the input processing break, any control, stripping, anything. And then I don't want also post-processing. If I want true raw terminal, I disable also post-processing in the output side. And I don't want also echo. So when I type, I don't want to see the characters I'm typing echoed by the terminal itself. I want full control, and so forth. I don't want the handling of signal and extended char combinations and stuff like that. Let's see how this works. So if I just enable raw mode and I try to chat again. Okay, let's see. To start, once the output is also put on raw mode, as long as I see the welcome message from the chat, the cursor is not even returning back to the start of the terminal, because the chat is sending the welcome message like that, like blah blah \n, but to the carriage return is \r, which I'm not sending here. So here there is this initial problem. Also, I can't see any input here, but probably I can see it. Okay, let's kill telnet, because the terminal here is in an unwell state. Okay, so if I type something here, you see I can see each single keystroke, because do you remember that our server didn't implement any buffering? So I see every different keystroke will produce a different write to the socket, and the server is not doing buffering. So I see every single character here, S and H, F, and stuff like that. This is not what we want. So in order to make this working well, I need to implement some minimum line editing. So this is the main loop of our program, of our initial very simple program. But instead, as there is more data readable from the terminal, instead of just writing it to the client, I call input buffer feed char. Basically, with this set of function, I implement an input buffer. Let's see how it works. Minimal line editing. To start, I want a couple of functions that will perform, will emit escape sequences for our terminal in order to do like clear the current line. So erase everything, erase everything that the current line is showing, and then put my cursor at the start of the line, which is just emitting carriage return character. It's very easy. Then I want some minimal state, a buffer and a length of the current buffer the user is typing. and a couple of generic return values for this set of functions. Error, okay, got line. Okay, so this is a very simple function that takes as input a pointer to our structure, buffer structure, and a new character, and it will just append the character. So we'll append it as the next available character in the buffer, and we'll increment the length. This is a more complex function that builds on input buffer and is the one called every time there is a new keystroke to read in the terminal. Let's see what this function is doing. So if it's a new line, we ignore it because we don't want to append a new line to our buffer. We are interested in the logical thing the user is typing. If it is a carriage return, yes, we want to signal the user that we have a full formed line. When the terminal is put in raw mode, 127 is the backspace code. So I want to trim my buffer, assuming there is some buffer, I trim it. And the default with any other character is to append it to the buffer and to write it to the terminal in order to have, this. I disabled completely echoing, so I want that when the user is typing something which is meaningful, I want the user to see it. And then I have a couple of more interesting functions. Input buffer hide is just clear the current line, put the cursor at the start. Input buffer show is just print what is in the current buffer just to the standard output, and that's it. And I also have a function to clear the buffer when the user typed the full line. I want to set the length to 0 again to start a new line. And also when this happens, I want to also hide the current line that the user was typing. That's it. If I compile this program and use my small chat client, I can type new line. As you can see, when I hit new line, it's clear, but I have no any history of what I'm typing. However, I as you can see, the chat server is now returning the right stuff, fully written lines. Also, I have backslash handling is not functioning, but we will fix this later. Let's see an important piece of this program. So, input buffer feed jar. Okay, when this function returns got line, what I do is append a new line because the server expects line terminated by the new line, write it to the socket and clear the current line. Okay, this is why I no longer is the program is no longer sending each keystroke, because now the buffering is accumulating. When the user finishes the line, we just send the whole line that we have so far. Let's see if I can understand why backline is not working. Oh, I think I know why. It's actually working. See, 1, 2, 3, 4, 5 backslash new line, and I see only the first 3 bytes. So the problem that I have here is that when I trim this, I want also to refresh the line, doing like input buffer hide and input buffer show. because I want to refresh the new state of the buffer. Let's see if this works as expected. What's the problem here? Okay, the problem here is that I need prototypes for these functions that were never declared. Okay, now it is working. You see, I'm handling what you normally have in the terminal. Here we are handling it directly ourselves. We are re-implementing part of the terminal, basically, of what a terminal would do. Okay. Yes, now it works is okay, and as you can see the line is working. Okay, but we wanted to fix a given problem here, that is, while I'm typing, I want this to handle well, to be handled well. So let's type from netcat something else, and still I have this problem. I'm typing and I see data here, but this time we are in a much better situation because we can finally fix this. Basically, the problem is here, right? When the socket has new data, I read this data and I write the data on the terminal, but the user is probably typing. So here what I can do is input buffer hide, and I write the new line, and then I show what the user was typing. So I'm just removing the user input, showing what I get from the server, and restoring again the state that the user was expecting. Let's see what happens now. Hey, I'm typing, some new message arriving. Oh, voila! As you can see, this is the new message arriving, and I'm still am able to type, and the message arrived okay in the other side. Very cool. I believe that for this moment we can stop here. Maybe just a thing. At this point we turn this into some live coding sheet. At least I want that when I write, I see this as something I'm writing. Let's see if I can do this. Okay, got line. Basically, after I write this to the socket, or actually before I write it to the socket, let's do this. So write std file no std out, but also I before want to write something like u, and these are 5 bytes, right? 1 2 3 4 5. Test. Yes. Okay. Only problem is that I want to before writing this, I want to hide the input, the current input. test 1, 2, 3. Perfect. It's great. Okay, I'm happy with my program, and this video was long enough. Bye.